Hey, this is Dr. Williamson, and I'm going to go over some acid-base properties of salt solutions, to go over the hydrolysis of salts in water, and we're going to see we're going to learn how to analyze them. First thing we need to do is remember the list of strong acids that I had you guys learn, which is hydrochloric, hydrobromic, hydroiodic, nitric acid, perchloric acid, sulfuric acid, which is strong in the first H only. Then the list of strong bases, which is right here. And then a couple things I want you to do. Water, which is H2O, which I've kind of written like this. It's actually a bent molecule, or I didn't draw it bent, but it's a bent molecule, where the hydrogen is electropositive, the oxygen is electronegative, and this other hydrogen is electropositive. Okay, and it's bent. I didn't draw it bent. I should have. Okay. And then what we're going to do is we're going to kind of mentally cheat, and we're going to think of water as being made of H plus and OH minus. It's not really. It's made like this, but bent. Okay. It's made, I should draw it properly. I should do this. This is a closer approximation of how water is built. Okay. But we're going to kind of use this. And what we're going to do is I'm going to give some salts and our three-step process that I'm going to have you guys learn to analyze whether a salt put into water, whether that salt will make the solution acidic or basic, is step one. We're going to break the salt into its separate ions. Step two, we're going to react the cation with the water, and we're going to think of the water as H plus and OH minus, to see if a strong base is quote unquote formed. Okay, it's not going to actually be formed. And then we're also going to react the anion, which is the negatively charged part, negatively charged ion from the salt, to see if a strong acid is quote unquote formed. And then we'll be able to determine whether or not the solution is either acidic or basic. You'll see what I mean by example. So let's take, for example, sodium fluoride, NaF, solid. I got some sodium fluoride. I got me a, over here, I'm going to draw let's do this. I'm going to draw okay. There. I'm going to draw a beaker of water. And then I have some sodium fluoride. Solid. Crystals that I actually have in my hand. Well, not in my hand, but it's a parenthesis mark. But, you know, in a scupula. Then I'm going to take those solid and I'm going to drop it into the water in here. What happens? Well, the sodium fluoride, once I dump it into the beaker of water, is going to break up into sodium ions plus, and since it's dissolved in water, we're going to write AQ to remind ourselves and our readers that it's dissolved in water, it's aqueous. Plus, it's going to separate into fluoride ion. Here, AQ. Aqua, right? So that's step one. I break it into its separate ions. So here it broke up into, I don't have the space to write it in here, but you guys get the idea. Step two, I'm going to react the cation with water to see if a strong base is formed. Which one is the cation? The cation is the positively charged ion. So I'm going to take my cation, sodium ion, aqueous, and it's going to react with the water, H2O. This is the part where we're going to kind of mentally cheat. We're going to think of that as H plus and OH minus. And what part would Na plus be attracted to? Would it be attracted to the H plus or the OH minus? Well, opposites attract. So the sodium, positively charged sodium ion, will be attracted to the OH minus, right? Will be attracted to that. And the reaction would potentially like to make H plus aqueous, right, floating around in water, plus Na OH aqueous. Except we've learned that sodium hydroxide is one of our strong bases, and it does not stay together. It forces the reaction and it drives the reaction backwards. It separates back in half and it drives the reaction back this way to where we started. So this reaction does not happen. It tries to happen, but it doesn't happen because every time I try to form sodium hydroxide and have it stay together and have some leftover H plus floating around in solution, that doesn't happen. The sodium hydroxide separates back because it's a strong base and makes the reaction go backwards, and we end up back where we started from. So I end up with sodium ions in the water back where I started from. So that reaction won't happen because the strong base won't stay together. That's the definition of a strong base. Okay, so that reaction, step two, does not happen. Step three, fluoride ion, right? That's the anion, the negatively charged ion, fluoride ion, aqueous, AQ. That's kind of sloppy there, but you guys get the idea. Plus, I reacted with water, the H plus, OH minus. That's liquid, by the way, right? It's water. And it's in a beaker, so it's clearly not water in a gas phase, right? What part would the F minus be attracted to? It'll be attracted to the H plus, and we'll try to form HF, aqueous, plus, and what will be left over? OH minus, aqueous. And I take a look. Oh, that's an acid. Let's go look over here. Oh, it's not on my strong acids list. It does not force the reaction all the way back to the beginning because it's a strong acid. So what happens is I end up with this reaction going backwards partly, but not 100% backwards. So I end up with it going backwards partly, like I said, but not 100% backwards. So I end up with this reaction going into equilibrium. That means once I put some sodium fluoride into the solution, I end up with some excess hydroxide ion floating around in solution from more than before. And I end up with my solution now in here being basic. Because of this third step, meaning I had some hydroxide left over. Okay, that's how we do that. Let me erase this, and we'll try to do another one. If I could erase this without erasing all the other stuff that I forget. Okay, let's try. Let's see if I can. Let's try here. NaCl. I want to do it in. I want to do it in black. So we're going to go NaCl. Solid. Right? So let's erase this. And I've got NaCl solid. Erase that jazz. And I put this into water. It's going to break up into Na plus, aqueous, plus Cl minus, aqueous. That's step one. So now, in the first instant, I've got sodium ions floating around in there and chloride ions floating around in there. But you know what? Sodium ions have a positive charge. And if they have a positive charge, they'll be attracted to things that have a negative charge. And we're thinking of water as H plus OH minus, right? And so we've got H plus OH minus. That plus will be attracted to the OH minus, and it will try to make NaOH and leave some H plus excess floating around, right? It stripped off the OH minuses off the water, left some H plus laying around. This is here liquid. This will be aqueous, AQ. This will be aqueous, AQ, and this is supposed to be a plus sign. If I take a look at this here, this is a strong base. It's on the strong base list. This will not form. It will not stay together. That means it forces the backwards reaction all the way to 100%. It won't stay together. It gets divorced, goes all the way back. And so we end up with here is no reaction. I don't end up with either one of those being made. So let's see what happens for the third one. We've got Cl minus, aqueous, plus H plus, OH minus, aqueous. The Cl minus will be attracted to the H plus because they're opposite charged. We'll try to make HCl. Oh, by the way, dumb mistake here. That's not aqueous. That's liquid because it's H2O in water. Water in water is liquid. HCl aqueous plus what's left over when that reacts with that, I end up with OH minus. Aqueous. Right? Tries to make that. However, HCl right here is a strong, HCl is a strong acid. That means it 100% ionizes, breaks apart, and forces this reaction completely backwards. And that means I also get no reaction here. And so what happens? What happens is when I put sodium chloride in water, I end up with salt water, Na plus, Cl minus, and the pH doesn't change. It stays at a pH of 7, assuming it was pure water to begin with, and then I threw the sodium chloride in there. Okay, that's basically how you analyze it. In the next installment, I try and do some other problems similar to this, but that's how you do this.